And good evening, everyone. So today is the 7th day of our AI Accelerator, and we're here in London starting our live stream. And today we only have one special guest for you. And this very special guest is already on the call with us, and it's Inderpal Bhandari from IBM. Inderpal, good morning. I know it's morning in New York still. How are you?
Good morning, Elena. Very nice to be here. Good morning, everyone.
Thank you so much for joining us. So we have a very special keynote today, and I'm not going to be spoiling this for anyone because I'm really looking forward to hearing this live. But we have some fantastic insight that Indrapal will offer into what AI is, what AI does, and also the future for this technology. We will then break for a 10 or 15-minute Q&A with our young participants who are already listening to this talk. So Inderpal, it's over to you.
Thank you. So once again, it's great to be with all of you. I'm going to first give a brief presentation, maybe around 15-20 minutes, and I will talk about what AI is, the way I've seen it develop, and also where it's going to go. After that, we'll open it up for questions. So please do put in your questions throughout the talk. And as many questions as you have, I will address them at the end of the talk. So that's the plan. In case you're wondering why the title of the talk is Slam Dunk with AI, it's because I will use an example from basketball, particularly the National Basketball Association. So I've had a very long history with AI myself. When I was a PhD student at Carnegie Mellon University many years ago, we are going back now to 1985, I was well through my thesis work. But in about 3 years, I was closing in to finish when I met a gentleman on campus whose name was Herbert Simon. And I found out later that he was one of the fathers of artificial intelligence. He has a very famous book called The Sciences of the Artificial, which is like one of the Bibles or the holy books for AI. And there were 4 founders. He was one of them, Herbert Simon. So I became very, very fascinated after talking with him with the whole field of AI. And what ended up happening was I restarted my PhD with him as a co-advisor and started working on an AI topic. The AI topic at that time, there were expert systems, which were actually systems that could do one single thing at a time, like diagnose a disease or repair a car engine or something like that. And I was quite puzzled as to how people can solve many different types of problems, right? The same person can figure out how to do some complicated exercise, can figure out what's wrong with their diet, can repair a car, can do all kinds of troubleshooting activities, which a computer at that time just did not know how to do. So my thesis topic became, how do you generalize troubleshooting? How can a computer program exhibit that kind of behavior that would enable someone, the computer, to actually troubleshoot and diagnose many different types of situations? And Simon agreed to become my co-advisor. So I got a very, very early start in AI. Now, once I'd finished the thesis, and we can talk more about the experiences with Simon because they were very, very instrumental in shaping my career and also the way I think and what I did for the rest of my career. So we can certainly address that within the questions. Then I joined IBM Research. So this is my second time I'm with IBM. I had joined IBM Research right after finishing a PhD. And what ended up happening then was they said, you have created this computer program that exhibited this different types of troubleshooting behavior. And the way it did that was it could diagnose any computer board. So if you took out all the computer boards of a computer, there's the memory board, the input-output board, there's the processor board. They are very different. And this computer program was capable of troubleshooting all those boards, the same program. So they were quite impressed with that, IBM was, and they asked me to start working on their software processes, which, so IBM produces and used to produce and still produces a lot of software. If that software and we also have millions and millions of customers, if that software goes out and it still has defects, which is the fancier word for bugs, defects in the field as they call them, then it becomes very difficult to actually deal with that situation, because now it's multiplied millions of times at every customer that you have. And so they were looking to me to come up with a solution to help resolve the problem with the software process, so that by the time the product shipped, it had very few errors. And that backed me into the field of what used to be known then as data mining, where you started looking at data to find counterintuitive hidden patterns which nobody really knew. And we applied that to IBM software processes. It was quite successful. And then, because I was at IBM Research at the Watson Research Lab, they asked me, well, what would you like to do next? Because we give a lot of autonomy to our researchers. We let them come up with ideas, we let them think for a living, and we let them solve problems that are very relevant and difficult in the world. We give them the freedom to go off and do that. And I had the idea that, because this is, remember, we are talking now about 1990, the internet was just taking off, and I had the thought that data is going to be a way of life. Everybody's going to have to deal with a lot of data. And so I came back with that proposal that we should really design a computer program that can help the everyday person, the lay person, deal with data. So you don't have to be a statistician, you don't even have to be an engineer, you're just doing your job, and you're able to deal with the data that you're confronted with. Now, at that time, they asked me, the IBM executives asked me to come back with a proposal showing how this would be useful, because they didn't really understand it. We had, our clients were like the large banks who had full back rooms filled with statistical analysts who would do all this work. So there wasn't a clear market need for how one would proceed with something like that. And so I came up with the idea of applying data mining to the National Basketball Association. And that's why I call this talk Slam Dunk with AI, because you will see as we go through the talk how that thread of working with that AI program, I mean, I call it an AI program now, it was a data mining program then, but it was the earliest possible AI program that you could think of in the field of sports. It was well before Moneyball. In fact, many people have told me that I should have written the book instead of, the computer program. But that's a story for another day. So let's go to the next slide, and I will tell you a little bit more about how my view of artificial intelligence was shaped by working on that program. But first, I want to just give you a sense of how we think about AI at IBM. So there are 4 attributes for AI systems. I will not be talking about technology. I'm just saying, if you look at an AI system, there are 4 attributes it must have. They are the 4 E's. They're all spelt out with E. So they have to be an expert at something, right? It has to have some basic expertise. In the case of the old expert systems, it would be one particular aspect of one disease. Now it's more general. but they could be expert in, say, banking, could be expert in medicine, could be expert in, or a specific aspect of medicine, like a complicated aspect like oncology, which is another word for cancer. But it has to be an expert at something. So that's the first thing. First E is there has to be expertise. The second E is expression. Now, this is a very important point. You have AI systems come in two flavors. One flavor of AI system is what's known as a black box system, which means that you don't really know what's going on inside the system. And the other flavor is the white box system. So the white box system, you have to know what's going on inside because the eventual decision is being made by a human, by a person. The person is actually making the decision. And I'm going to give you a sense of why this is important by going back to the MBA program that I wrote called Advanced Scout. It was called Advanced Scout. You can still Google it. If you Google my name and Advanced Scout, you'll find all kinds of things about it. But it ended up being used by every team in the National Basketball Association at that time. And it was used by the coaches to prepare strategies for playoff games. So for those of you who are familiar with the NBA system in the US, you first have the general season, and then after that, you go into the playoffs. So the playoffs are played in best of 5 or best of 7 series, and and it's a knockout. After that, those 5 or 7 games are over, or whoever wins, if you get to 3 and 5, you've won the series, and so forth. So in playoff games, these coaches would use this program called Advanced Scout to find counterintuitive patterns, to understand who to put on the floor, which players to have on the floor when the other team had XYZ on the floor. At what time did it make sense to put them on the floor? What plays should be run when you had them on the floor? Things of that nature. So lots and lots of data, lots and lots of attributes. And this program would find these patterns. But I will never forget the first time that the program came up with a counterintuitive pattern. It came back and told the coach, you have to play your backup point guard and your backup forward in your next starting lineup. Now, this was a team, they were down 2-0 in a best of 5 series. And they had this computer program was saying, you've got to play 2 backup players. That's like saying if you're based in England or Australia, and it's a cricket match, you're going to say, oh, don't play your top two openers. Play your 8th and 9th batsman up top, and then play the other guys later. So the coach called me and he said, Inderpal, how am I supposed to follow this? Because if I make the wrong decision, not only will I lose the game and lose the series because we're 2-0 down, but I'll also lose my job. So think about that, right? When you have a very important decision and you have a computer program that comes back and gives you some recommendation, and if it is unable to explain the recommendation to the satisfaction of the decision maker, it will not be followed. It's like telling a doctor, yeah, I think this person's leg needs to be amputated. The doctor is not going to just go off and amputate the leg, no matter how sophisticated the program. The program has to be able to express itself like a human, right? That's how the interaction has to be human-like. It has to be in natural language. It has to be able to provide options. It has to be able to reason about the options, lay it out before the decision maker so that they can go off and make this decision. That's why expression is extremely important in the context of white box systems. Now, in the case of IBM, we're all centered around white box, because then there are other things that come into play within AI systems, like bias, like making decisions that are suboptimal. So unless you really know what's happening in the system and it's able to explain its reasoning, for important decisions, decision makers will not follow the computer program. Now, the way we solved that problem in Advanced Scout was I had the brainwave that we would take the video clips in the 2 games that they had lost when those 2 players were on the floor, and then the coaches could look at that and understand what was going on. And when they did that, they began to understand that their backup point guard was very, very fast. And even though the other team had one of the best point guards in the league, if not the best, he could not keep up with the speed of this other player. And that made him tired, and then he didn't perform as well, and so forth. So they began to reason everything out. And they made the decision. They actually went and started those two players. They won the next two games, and they lost in a close battle in the fifth game. So that's the kind of things that is possible, but it was only done because we were able to explain it. We found a way to explain it. So that's why expression is extremely important. Then educate. Now, these are the more modern AI systems. You don't program them. You don't actually write code like you did with the older systems, like when I did my work. In today's world, you educate these systems. You show them data points, you show them examples, you show them edge cases, and that's how these systems learn. Much as we learn from them, they learn from us. And that's why educate is extremely important. And the reason I say that is, as the world changes, and by now I think you might have guessed that I'm a believer that we are all going to have to deal with these systems at every facet of life, because we're going to be surrounded by so much data, and that's the only way to really deal with data. So we have to get comfortable being able to educate these systems, learn with them as we go off and do our things. And finally, this is, of course, the main promise of these systems. This is why they're so successful. These systems are able to evolve. So they can take massive amounts of data and process them and learn from them and come back and make recommendations. So just to give you an example, the state of medical knowledge, what you see in journals and so forth, that changes so rapidly, and it increases so rapidly that it doubles every 72 days or something like that. Some, really a small number, it's doubling. So you can imagine what's happening in the world as more and more data is being added to the system. And so how do you keep up with that? So for another estimate we had was, for a doctor to actually try to keep up with medical journals, they would have to spend 160 hours every week. So that leaves no time for patients. It barely leaves time for them to sleep. So these systems then, it means they are a necessity. So they're going to essentially hit every facet of life. We will all be dealing with it. And so that's the key thing to remember with regard to that last T, that these systems are able to evolve. They are able to evolve at speed. They keep pace with the data. This is why it all becomes very important. So those are the 4 attributes of AI. Next slide, please. So I talked about the MBA program. I'll give you I'm going to now just explain one other very critical aspect of what's happened since I worked on this, on the Advanced Scout program. So if you think about that trick I played where we highlighted the video clips of when those 2 players were on the floor, right? We could actually do that. We could just bring out those clips. When we did that, what happened? What actually happened? What happened was that the coaches could see the context around the pattern, right? In the original case, we were missing the context. They couldn't see everything else. And the reason for that is you can't capture everything in terms of data in the world. You're always going to have missing variables, missing context, et cetera, et cetera. So there's got to be a way to bridge all that context so that you can actually make a much better decision. Well, today, the AI systems are actually able to do that. That's because they process multimedia data, right? They can process video, they can process audio, they can process text. And when you put all that together, again, these systems are able to put all this together, you get an ability to weave in the context, which we didn't really have 2 or 3 decades ago when I was working on this stuff. So we had to manually bring that to bear in the program. But those are the 2 reasons why these systems are so powerful. One being that they evolve with the data. You can keep pushing data at them, and the hardware is so powerful. The software today is so powerful that it can actually process all that and learn. The second is multimedia data. You bring all the context together, you're going to get a much better result. Also gives you some sense of if you are designing these systems and you want to really make an impact, if you go after those two things, the scale of the data as well as providing the context, you're going to get a better result. So next slide, please. So today I made that comment that, these systems are able to actually go after this multimedia data. So there are many, many different arenas where it's used. And we have, of course, our Watson family of tools, AI tools that are applied across the board, across many, many different industries. But the points I made about actually how the coach was able to see that this player is faster, they're able to move much faster than the other player. The other player then has to give them a gap. That all those aspects you are able to understand by using these systems. So these systems will allow you, for instance, it can recognize in a basketball game how much distance a player is giving the other player, what kind of speed is the player moving at, where is the player positioned. In the case of golf, when is the player giving basically a fist pump so that they're excited? The sound from the crowd, when does that actually denote celebration versus disappointment? These systems are able to capture all that. That's why you're able to craft highlights automatically and put them forward. In fact, Watson created a whole movie trailer for a movie called Morgan, which was a horror movie. It went through about 100 trailers of that genre, the horror movie genre. And then it looked at video, audio, scene composition, et cetera, et cetera. And eventually it created a trailer for this movie Morgan, which was, basically created by an AI system. So it gives you an idea of what AI can do. It brings all this context together. It's able to scale with the data. You put all that together, you have a very, very powerful capability that helps you deal with what's happening in the world today. Next slide, please. So I just want to say one other thing in terms of the vision for the future, and I'll illustrate it with another anecdote as to why these systems are going to proliferate through every aspect of human endeavor. So obviously there are many different places where these systems are being used today, but I'll give you a sense of the future, what that looks like in a business. In a business, no matter what job a person is doing, they will be working with an AI system. And I will give you the example from my own area. There is a person, this is an entry-level job. There's a person who, when we get data about IBM customers, their job is to research whether or not a particular company that we are doing business with is a government-owned entity. And the reason for that is government-owned entities, you have very special rules and regulations and laws for how you deal with them. And those rules and regulations and laws, they vary by country. So it's complicated, right? We're a global company. We absolutely want to do our business ethically. And so it's important for us to know whether or not this particular customer is a government-owned entity. And this person essentially does research on the company. They might do some internet research. They might talk to some people. They might make some phone calls and talk to people at the company. They will then talk with our salespeople who will want to be very loose with the label, because they want to sell things, so they don't want restrictions. On the other hand, when this person talks with our lawyers will be much more restrictive and say, no, be conservative. You cannot go off and say this is not a government-owned entity. Anyway, long story short, very manual process previously, and eventually this person would come up with a label, and we'd be generally right. So once in a while we'd be wrong because this is the way this process worked. Well, now with Watson, Watson can essentially not only look at the data that we've amassed in the past dealing with customers and so forth, but it can also look at the real-time data. What press releases are going out, what news articles are going out, what are people saying about the company, what's the sentiment. And so it can do things like, oh yeah, there's just this press release that the government acquired this company, which obviously would mean it's a government-owned entity. But even more subtle things like, oh look, here's another press release that the founder of this company is now being appointed to a high-ranking government committee. Now, that may not mean it's a government-owned entity, but it's relevant to the decision. Now, that's an entry-level job. There are literally thousands and thousands and thousands of such jobs within IBM. And what I'm saying is that across every process that we have, we are infusing AI. So in a sense, those thousands and thousands and thousands of decisions that people make across the company are going to be infused with AI. It will be more accurate, more better. And the reason I say it's more accurate, that's because, like, if you go back to that example, they're getting all the latest information, which they couldn't get otherwise. But apart from that, it'll also help with all the interaction between the legal and the sales teams and this person. It will streamline all that. So it'll also become much more efficient. So much better decision, much faster decision, and then you're going to have a much better business. So that's eventually what this is going to look like, and why I think it's extremely important that we not only understand how to program these systems, but also how to work with these systems, because that's what the general public will be doing. So let me pause there. And I believe that is the end of my presentation. Is there another slide? No, I think that's the end. Yes, no, we talked about it. That's the end. So I'm happy to take whatever questions you have, and I'm going to flip it back over to Elena.
Perfect. Thank you so much, Inderpal. That was really, really insightful. So I have the first question that I would really love to kick off this conversation. And the first question is, where do you see AI make the biggest impact in your view?
So I will tell you where I would like to see it make the biggest impact, now, given the situation we're in. So I think what the COVID-19 situation has exposed is how vulnerable we are to a pandemic. And not only vulnerable from a healthcare standpoint, because people really don't know the answer. They don't know what to do. We're going to do a vaccine, but then the vaccine's not here yet. So how do we cure the people? How do we look after them? So no matter which way you look at it, I mean, there's a weakness there. But also in terms of how you cope with being in quarantine, right? Because which is kind of the tried and true solution all the way back to the Spanish flu 100 years ago. That's what people did. So, but again, that's tough because the economy suffers, people's mental health suffers, et cetera, et cetera. So I think that data and AI are going to be radical in transforming that situation. And I'll give you my own example of what we learned during the pandemic. So the first thing we did when we had the pandemic was we already had an AI program that looked at our supply chain, because we supply things globally. So looked at this program called Operational Risk Insights. It looks at our supply chain, and then it overlays any natural disasters like hurricanes, earthquakes, even political upheaval. And it then makes an assessment as to which suppliers could be at risk so that we can make adjustments and continue the business. So the first thing we did was we essentially overlaid the incidents of COVID-19 around the globe as they were unfolding onto that program, so that the different areas in our company could also figure out how to continue their operations in light of what's coming. But the other thing that we learned was, because it was a brand new situation, a lot of the models that were trained on historical data, they weren't really that useful, because we didn't really know how to. And that's one of the big vulnerabilities. That was a real insightful moment for me when I realized that there is a whole new area here, which all has to do with making decisions around real-time data that's disseminated very, very, very rapidly, but then you have to be able to trust it. So it has to be very trustworthy data. And then you need the AI systems to rapidly learn in real time and come up with judgments, which they should be able to explain. And that, again, that evolves, right? So they kind of have to go through the whole cycle again. So the luxury of training a system, that is not as relevant as being able to deal with the real-time situation. So I do think that that's going to be an area where data and AI are going to be critical. And I think that's, there will be major impact there, because we realize now just how weak the systems are with regard to those aspects. But outside of that, I think every area, every business area, every process that we have, whether it be finance, and within finance, pick something like accounts receivable, or if it's marketing, or it's sellers getting early intelligence on customers, or research, or even my area, it's just AI is going to be pervasive across the business.
And talk to me about the COVID response. We've seen a lot of really incredible stuff happening across the globe. What really excites you about the responses that we have had? I mean, from NGOs to charities to global corporations, it's just been incredible how everyone responded and reacted. Have you seen anything in particular that really, excited you?
I think it's and people respond this way in a crisis, right? They kind of come together and they help each other. And which is kind of in some sense what these organizations like NGOs, etc., what they do, and the frontline healthcare people, and so forth. And I think that response was really the most heartening aspect of COVID-19. But I would add a counterpoint. I think that we can help that response if we're able to really disseminate trusted, reliable, real-time data and intelligence to those same people, so that they can, it just makes that particular task even easier than what it is. I mean, right now it's very hard because they don't get the data. They're flying blind, so to speak. And if they were able to rapid. I mean, even today, if you think about it, some of the countries are doing quite well with COVID, but I don't know if we have a really good understanding of what they're doing different from other countries that are not doing so well. And so, in some sense, as a scientist, when I look at this, I think that there is a massive opportunity because there's a big world experiment going on, real world experiment. Right? I mean, I painted the example of countries that are doing well versus not doing well. There's all kinds of data that's available globally. And so this is a perfect area for data science, AI, and for young students to take a look at. If you think of it in terms of real world experiments that are unfolding as we speak, and you're able to analyze what the differences and similarities are and come up with some conclusions, I think that could be incredibly useful as well.
And talk to me about some of the ethical implications of AI, particularly in relation to COVID, stuff that you have seen that maybe have raised your eyebrow. That's something perhaps we may not have noticed happen before COVID, but we are allowing this to happen as a form of experiment, such as contact tracing and stuff like that. Is there anything that concerns you about what's happening right now? Are we creating a precedent?
Yeah, so, it's, I think the way I look at it is as follows. And I'll go back to data science and AI and frame it in that regard, right? When you do AI, data science, eventually there is a model that's created. And when you're kind of an initial student, or either your first few experiments, you end up creating one model and you try to apply it and it's wrong. And then you learn and realize that really what you need are many models, because these models perform differently in different circumstances. So then people end up with an ensemble of models. And ensemble modeling, it's an art in of itself. And you saw this play out in COVID, right? You had the epidemiological models, they were wrong. The virology models, wrong, etc. You kind of, but then at the end, the ensemble modeling piece of this is an art. And if that's weak, what I realize in this COVID-19 situation is the ensemble essentially becomes political. How it eventually gets put together becomes a political act, as opposed to an analysis act or a scientific or anything else. And it has its own logic. So there's work to be done there as well in terms of ensemble modeling. I think people, they go in with the best intentions, but we do know that if you're looking at anything like a complicated data set along the lines of one model, it's not going to work, which is pretty quickly where people land up. And then, if you're not able to do an effective job of the ensemble, then it pretty much, well, the politicians step in to resolve that because they have to make a decision, right? I mean, you can think of it from their point of view as well. They've got to make some decision. They got to make on some basis, and that's where that's kind of how that moves forward. So yeah, no, which is why I was talking about that we do have to come up with a way to better what we do with regard to AI and data science in a real-time context where data can be shared in a trusted way, where privacy is maintained, and you're ending up with the right decisions rapidly to help people. So in the sense that ensemble we need to work on in a scientific way as well.
Absolutely. We have a question from Blessing. So she is asking, how can IBM help teenagers get into AI? So let's talk about teenagers and what they should be involved in, what advice perhaps you could offer to them, and what skills you think they should be learning, and whether there is anything within IBM they can get involved with and demonstrate their voice.
So, IBM has a tradition of involving high schoolers in the work that we did. So the Advanced Scout program that I talked about, when I was a researcher at IBM Research, one of the key members was a person called Zach Pines. Zach Pines was a teenager when he started working on that project. He was, I'd say, probably in the 9th grade in high school. And so he was, maybe 15, 16. But he was very passionate about basketball and he wanted to so he came in as an intern. And then, we had the most delightful times when he would be talking to these 6'9" basketball players and coaches, and he would take them through what he thought what the program was essentially saying. And he was instrumental in helping us with several aspects of that program in a hands-on way. So we have those opportunities in terms of internships and so forth across the company. And we also support actually employment programs at the level of it's more in terms of trade school. I think that would be the right way to think about it, as opposed to university. So we also bring in numbers of those people to work with us on our cutting edge initiatives as well. And so we have there's a whole list of different things that we do, and we can certainly, there's some information that will be available on the IBM website, but if they wanted to get more information, we'd be happy to provide it.
All right, so I hope, Blessing, you are happy with the answer, and probably there is a lot more on the IBM website. But Inderpal,
if she were to send an email either to yourself or just basically to us, we would help her find that out. But there's a lot of possibilities, and we do engage early with students.
And we have a few students, Blessing including, who come from Africa. Do these initiatives expand as far as Africa as well?
Yeah, we're a global company, so the initiatives will be everywhere. I don't know exactly where they're located in Africa, but we certainly have initiatives in many parts of Africa.
Okay, perfect. Then that's great. We'll share this information. So something else that I know teenagers are always sort of curious about is obviously your career probably wasn't just going, like this in linear way. Have there ever been any situations where you have faced some hurdles, some hardships, and how did you deal with these? because right now the young people, particularly part of this program, they all come from so many different backgrounds, and every single one of them has got difficulties and hardships that they have to endure during the times of COVID. And I often ask our speakers to offer some piece of advice or some stories that maybe, stuff that happened to you and how you dealt, and in the hope that that could also inspire them to deal with the difficulties that they are experiencing right now, because we are expecting definitely the young people of this age to be hit the hardest. And mental health is, issues on the increase. And how can they cope with what's happening right now? And can you give us some examples?
Yes, no, absolutely. So I will, I would like to pass on one piece of advice. And it came to me very late in my career. So I didn't realize that till much later in my career. And in fact, it was Professor Simon who was the one who brought it home to me. So I will tell you that story, how that happened. I told you I stopped the thesis I was doing. I restarted my thesis to work with him. And the very first time that there was a paper that I wrote, I left it with him. I left a draft with him. And this is this person he won the Turing Award, he won the Nobel Prize in economics, he won the highest prize for psychology and political science. So he was a very, very accomplished academician and researcher, and obviously very busy. And so I had given him this draft, and when I came back to see him, he always scheduled these 1-hour meetings. So you had to be very prepared, because otherwise you would just sit there looking at him, So that's one piece that, you have to be prepared when you show up. And he drilled that in by doing that. But when I showed up there, he took the paper that I had left for him, and all I saw was a sea of red, where he had corrected every little mistake, most of them grammatical mistakes, mistakes in terms of simplicity of expression, things like that. It was a sea of red. And he said, here's your paper. Now bring it back to me when you've written it in English. And that's how that message came home to me, that this aspect of communication is essential. And I've learned that no matter what stage you are in your career, that's one skill that's going to serve you really, really well. And you have to be able to communicate well in writing, in speech, no matter what you do. All forms of communication have to be good for your career to blossom. And what do I mean by communicate well? There's just one simple thing that, we have to remember. The communication has to be clear. It's clarity. That's what it is. It's not how flowery it is or anything else. It's because as you start on your career, and as you rise, you will deal with more and more people. You will deal with groups of people. You will have to influence these people to do things in the way that you're recommending. They'll have to see it. But just like I talked about the expression for the computer program, the expression for the human is probably as important. And clarity, I think, is the biggest focus. Because if you're not clear, people don't know what you're saying, and they can't really follow you. And then everything breaks down.
This is very relevant because they will all have to communicate their vision on Friday, and I can't wait to see them all pitch. But communication is something we also do insist on, and we try to develop that clarity, because they only have 3 minutes to present their project. Like in the real startup world, and they will have 2 minutes from the judges. So what advice would you offer to the young people exploring AI for the very, very first time? So this literally, for many of the students, this really was their very first exposure. They have never heard about AI, or they haven't heard about AI in a way where they knew this would really have the potential to make a difference. So they've heard about AI from sci-fi films and whatnot, but it's the first time they started exploring it as a technology, and as a technology or a framework that has so much more to offer. So imagine you're well, in your teenage years or, just starting university, again, you're speaking to that incredible model of yours, your professor. Thinking back to those years, what would you have liked to hear from people, like him or, other role models around you?
So I would say, I'm of the belief that AI is going to be pervasive, right? It's going to be applied everywhere. So the guidance I would give is figure out what you're passionate about, which area, and it could be anything. It could be music, it could be your family, it could be sports, it could be, like a basketball or soccer or whatever. I mean, pick some activity that you really, really are passionate about. And then figure out how to apply AI to that activity to take it to the next level. I think that's an exercise that's pragmatic, that people will respond to because they like to do that anyway. And it will also induce them to learn more and more about the technology and AI and how to apply it. And then I'm also a very big believer that by doing, you learn to surface all the different issues that come up, not just from, in terms of learning the technology, but also in terms of learning how to apply it, the ethical issues that come up and how you comport yourself, et cetera, et cetera. And so that would be my guidance as to what teenagers should do.
Amazing. And in terms of some practical skills or skills for the future, we focus on soft skills and hard skills. Are there any particular skills you think young people should focus on that will secure their future? So some may recommend, okay, you just focus on maths, and maths is everything. And we do obviously have some students who are really massive fans of mathematics, and they've all come to this program wanting to understand how, to develop models. But then there are others who really love the humanities. What kind of skills do you think they should be focusing on, apart from obviously identifying their passions and purpose?
Yeah. So I think we went through an era where specialization was key, right? And I think that so by specialization, I mean just focusing in on math or focusing in on coding and computer programming and things like that. I actually think that as these technologies take hold, those aspects will start getting easier. The interfaces to do those things will become easier and so forth. The other thing to keep in mind is these technologies change. They change rapidly, right? So for example, there's a whole new arena called quantum computing, which could just completely change how AI is done later on. But I think what's the constant is that these tools, etc., that you need to be able to do math, to be able to do computer programming and so forth, a lot of people will gravitate towards actually developing those skills, which is good. That's their natural strength, and they should go there and do that. But there will be other people who will not be drawn to that. And it's for them then that I kind of direct this next piece of guidance. I think they should focus on synthesis. Because all these interfaces, etc., are going to become easier, it's a question of how you put everything together. And this is where the people who, typically work in the liberal arts and they read up on philosophy and things like that are actually at an advantage because they are already used to synthesizing ideas in their minds. And so I think that aspect is kind of key as you move forward with this, because we will be dealing with these tools and eventually the decision has to be made. And the decision is one of synthesis, right? It's eventually all about synthesis. So I would say that I differ a little bit from the people who say just focus on math or just focus on programming and so forth. We like to have a diversity of talent and opinion. We have found that leads to better results. And people are understanding that even at the boardrooms, they're beginning to understand. And the reason for that is because eventually it's all about synthesis. And unless you have that diversity, you're not going to get the right decision.
Fantastic. No, I love this piece of advice because we do have a lot of young people who come from, non-mathematical backgrounds, and there is so much value they can add to the conversation. And in fact, our lead design thinker from Quantum Black, she's an ex-IBMer, but her original background was in architecture, completely unrelated to the tech as we know it. And I love the fact that people come into AI and data science from so many different backgrounds that you don't even, expect to associate with technology. So this is something that I'm really passionate about. Fantastic. So Inderpal, thank you so much. This was such a brilliant conversation and a lot for us to think about. So a lot of teenagers are sharing their thank yous on YouTube. We're really grateful for your time, and we will keep you updated. We have got one incredible keynote tomorrow joining us as well, and she's a former IBM. You probably know Harriet Green really well.
Yes, I know Harriet. Please give her my best regards.
I will send her an email, and I will definitely share your regards with her. And she will be joining us tomorrow as well. But we will keep you up to date with what we're doing with Teens and AI, and we really hope to have you again at some point in the future. And do stay well where you are, and keep an eye on what we're doing. We'll stay in touch. Thank you so much for joining us.
Thank you, everybody. Thank you. Bye.
Thank you. All right, everyone. So this was the only session we have had today, and I'm really grateful you've joined us today to listen to Indrapal from IBM. And so tomorrow we have one really important and keynote guest, and somebody who I am passionate about personally as a woman. She's an incredible person, and just during the lockdown, I learned she has been volunteering tirelessly every day. So she has a lot of stories to share as well, and she will be here to speak about the power of you. So please do not miss that very special keynote tomorrow. And I'm absolutely looking forward to hosting Harriet here live at 5:30 p.m. So on this note, I'm going to close this evening stream because I know all of our teams have got so much to do and accomplish today and tomorrow before the actual final submissions on Thursday. So there is a lot to do. They're all very busy coding and doing the most incredible stuff. I am very proud of everyone's achievements and every team's effort. You are all onto something very special, and I am just excited. I'm on the journey with you. So thank you so much. I will be seeing you back in Discord, and I will be seeing you back here at 5:30. Thank you.